So today I plan to start the build of this card. This is the H8 8088 Z80 64K RAM Org 0 card, designed by Norberto, Norberto. Hopefully you can see that. If you search Norberto 64K, you will find his website. Got a little coffee or something on the card already. Been really looking forward to this build. This card provides up to 64K of RAM for the H8. The Org 0 mod is on here, so it can boot things like CPM. It produces the second side signal for floppy drives, so you can actually have double-sided floppy drives. So it kind of takes a number of cards and combines them all together. It uses just standard TTL. If you've got a RAM that can be battery backed up, there's provision for a battery. Little prototyping area on the card, which is really nice. I don't know if I have the RAM chip. I'm going to have to dig. I've got a lot of pools and that kind of stuff, and it's possible I do have the RAM chip. Some of the logic that he defines is HC. I'm going to be running this in I believe a 1 megahertz 8080 configuration, so I'm not going to worry about that Schottky higher speed logic. I probably won't need it, at least in the configuration I'm in. Norberto has built out, I think like 10 megahertz C80 cards, etc. that run in the system. One thing to observe on the card here is the pin 1 notch on the RAM is to the top of the card, and the pin 1 notch on all of the TTL devices is towards the bottom of the card. There's a couple of spare socket locations here. There's a couple of 8-pin spares down here. There'll be a couple of dip switches on the card, of course with pull-up resistor packs. There's a rework note about the LED pads here, where the silkscreen has, I don't know if I can get this into focus here on camera. The LEDs mount here, however the silkscreen didn't clear the pad, so you need to go in and scrape the silkscreen off at 3 locations. I believe it's 3 locations. Yeah, there's 3 LEDs, 1, 2, and 3. So you need to manually scrape that silkscreen off. I believe that's covered in the errata in the assembly manual. I kind of read through the assembly manual in advance, so there's the note here where you got to go in and scrape the silkscreen off so that you can solder those LEDs on. Pretty impressed with the card. One of the things I haven't tried yet is this. Get this to open. So these are H8 compatible edge connectors, very similar to the ones that are on the older H8 cards. It's got these 2 little clips. I don't know if you can see this little L-shaped clip here that clips up under the board, and then these rock down into place to be soldered. I picked these up a long time ago, and I'm hoping they are compatible with the card. And they are. That one on there, very nice. So these are gold plated. The pins on my H8 backplane are not gold plated. I may at some point replace them all with gold plated pins, because I'm going to be putting 10 pins into gold here, and the similar metals don't necessarily like each other. When I first started lurking on the H8 forums thinking maybe I wanted to buy an H8, there was a post where somebody said, these are getting hard to find, here's a link, you should buy some. And I picked up 10 of them. I think they were $4 each, so they were very spendy. I'm kind of regretting now not buying more, although I think I've seen indication that DigiKey has a compatible connector. I don't know if it's the same one. One of the things I was very pleasantly surprised to find was when I got on the website the card supported and downloaded the information. There appeared to be KiCad files for the design of the card, and I'm really happy to find that. I've been working on designing just a generic prototyping card for the H8. I've got some projects in mind that I'll wire wrap. And I had designed my own footprints for things like this. I'm pretty new to KiCad. I played a little bit in the last 4.0 release, and I'm now in the 5.0 release. And it's coming together. It's just kind of, there's a learning curve, getting better at it. But I had designed my own edge connectors, footprints, and don't have the dimensions of the board really well defined. So having those KiCad footprints and symbols available will be very nice. This is, I don't know if it's called a half-length card or what, but you can see versus a standard H8 card, it's, I don't know, there'd be half. It's, I don't know, 2/3 the length of a standard card. Actually, I guess the orientation would be this way. I don't have these metal brackets, but this is really just channel aluminum that I think I can just go down to my home center and just buy some stock and then cut and bend. Now, even though I wouldn't have these pressed in threaded screws, I could still make a bracket like this. In the manual they talk about replacing the 7805 with a switching equivalent. I will probably do that, although the current draw on this shouldn't be too extensive. I consider this kind of a medium difficulty card. I think it's a little much for a beginner, although maybe not. If you know how to solder and are patient, the documentation looks good. Lots of detail. There's a separate bill of materials. There's kind of, you know, information here on heat sinking and pins, and they've actually grabbed text out of HeathKit manuals and created, you know, a little soldering tutorial here. I'm going to somewhat follow the order. Oh, they're looking for a 1 watt resistor there. I'm going to have to dig, see if I can find a 100 ohm 1 watt. I have the resistor values for all of these here except for, I believe, one, which is on the next page, I believe. Calls for a 3.2 k ohm carbon. Do I have a 3.2? The closest I had was that actually 3.2K or 300? 3.2K. Yeah, the closest I had in my bin was 3.3K, 33K. I don't know how critical that is. You know, he's calling out 5% resistors here, and that's a 5%. I think that'll be good enough. I will change up, I think, the assembly order of this. I tend to like to assemble a card in the order of the lowest profile components to the highest. So because the resistors all lay down on the board, they're pretty low profile. I'll probably do the IC sockets next and kind of work my way up to the highest profile. And part of that is you can, of course, lay the card over and firmly hold the component in place. For soldering, I don't know if I have an appropriate. Let me dig. Now I've got breakfast on the stove downstairs. I can smell it. I've got these lead forming jigs, just because you get a better looking job, and it looks like the spacing on those will, I believe, be the number 9 spacing on the edge of this one. Looks like it'll work well. You can hand bend as well, but I kind of prefer a nice clean. There's all the way down to 4 here. Oh, 0.4, so yeah, this one's in inches. I think this one's in centimeters, millimeters, I don't know. You know, I'm intending to actually bend the leads nice and clean so that it'll look good. So, you can see, I've got quite the stock of resistors, and I do. So we're going to start. I don't have the 100 ohm. I'm going to start with the 220 ohm, which is this bin. So we got 22s in the front, 220s in the back, and that is red, red, brown, so it is a 220. And there's 2 of these required. It was a pack, you know, I bought these on eBay, and somebody's actually gone ahead and stamped on these the values, which is kind of nice. We'll take the first one of these and drop him in and kind of center him. Do the magic bend, and then look for markings on the silk screen that say 220. $1K, $2K, 220. There's one right here, which is R2. Let's see if the width of that worked well. And it did. As you can see, that dropped in there very square, very nice. So that width works really well for this. Flare the leads just a tad. So you don't have to use a bending jig like this. Again, these were an eBay purchase. I don't even know if they make these anymore. They were inexpensive when I found them on eBay, and I went, you know, make a project look a little nicer. So there's one 220, and there's the other 220. So this is R1 and R2, it looks like. R1 and R2 were 220s. So now it's just a matter of soldering those. Let me set the 220s aside so I don't mistakenly pick one up. Of course, as you can see, the bench, as always, is a mess. I'd have it no other way. This JBC tip is getting somewhat old. I've soldered a lot of joints with it. Really like my JBC pencil. It was extremely expensive for a hobbyist tool, but I think it's more than paid back. It's just a really high quality, nice tool, and I actually made the investment to buy a large number of the tips for it, which again, some of those tips are as much as $40, but you know, when you need that tip, it's actually nice to have it. Hopefully I can get this into focus and on frame, or in frame. I don't know if you can see those. I'm very happy, although I got lucky. I didn't check the orientation to make sure they're both oriented the same way. I got lucky. Don't know why I didn't think of that. A couple of solder joints on the back, and the build is officially started. I do like to have the tolerance band the same direction. It doesn't really matter right or left, but just the same direction across the card. So I'll actually be a good boy here if I can find something that writes. I just said I like a messy bench, and I actually do, but it is very messy. I've always got my mechanical pencil laying right here. And of course, at the moment I don't, because you know, I'm looking for it. .330 ohm is this bin. And again, I'm 330. The next bin will be 3.3K, 33K, etc. And these are all, like I say, organized well. That is orange, orange, brown, so that's 330. There's only one of these. Boom. And I, of course, dropped it. Let me put the other ones aside and find 330 on the card here. 1K, 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 220, 2K. That's interesting. I don't remember there being a 2K in the bomb. So that's labeled R4. R4 is 3.2K in the build of materials, so that may be a substitution. So the 330 is at R3. Let me see if I can spot it. R3, 330. I've got the tolerance band to the right here. We then move on to 680 ohm. And there's 3 of them required. Yep, 680 ohm. Oh. 330, let me put that back in the right bin. Yeah, I will probably eventually either buy out of Norberto's stock if he has cards left for his processor replacement. I think there's a floppy controller, etc. He also provides information on ordering them from the manufacturing house. He has the boards made and basically says you can call and order off that, and that way you don't have the tooling fees and everything. It's just a reorder. So there's that 1 watt, 100 ohm. 680 R5, and I will put the tolerance band up. .680 R7. Of course, I'm not spotting it. Diode. I'm sure those are all string diodes for the battery backup. R7 680 and R12 680. Tolerance band is to the right. And these just slide in so nice when the leads are bent to the proper width. I just think it makes for so much nicer a build. But it's not, you know, mandatory. And again, just the resistor height here, I can push down on the board and get the resistors nice and tight up against the PCB. With that 1K ohm being requiring 1 watt, I would probably mount it slightly up off the board just to give a little better airflow around it, since speccing it at 1 watt says he does expect it to get warm. Really nice. Well, I won't bore you with the insertion of the rest of the resistors, except possibly for that 100 ohm 1 watt. Then I'll get the rest of these in and we'll pick up video and whatever I decide to install next. So I've got all the resistors installed except for the 1 watt resistor, which goes over here. I'm gonna not follow the order, the assembly, because I'm going to put the sockets in next. Again, it's just kind of a matter of preference. My normal process is to get a socket each corner. So it'll probably be these two and just this one here. And that way the board's kind of held up, and then you can just get the others in as needed. So I need two 20-pin, it looks like. So I'm looking for 20-pin. I'm actually running out of 20-pin sockets. I'm just going to use double wipe. We've talked about this in previous videos. There's a double wipe. There's a double wipe, and that looks like it's a 16 there. You may be able to see I have just a few 16 pin, although I'm running out of 14 pin. And I'll just grab a 16 pin. Oops. It would help if I didn't drop the 20 pins up there in the corner. I tend to buy sockets in bulk. It can take a long time to burn through them all, and I didn't get a match set. I do like them to be matched. Looks like there's going to be a total of 4 20-pin on the board. 1, 2, 3, 4, 1, 2, 3, 4, 5 actually. So let me dig out 5 matched ones. I'll put the there's 1, 2. 3, oh, got an extra there. 4, I tend to like to do sockets from the largest pin count down to the smallest. I have more than once dropped a 14-pin socket into a 16-pin footprint and got it soldered up before I realized my mistake, and then it's removal and rework and unhappiness and pain. So, because he's in the center of the board, I'm not going to do that guy first. We've got 3 more we'll want to install. What did I do here? I think I put the wrong one away. Yeah, I did. I do believe that's the 16 we picked, and it is. And keep in mind, oh, that's actually a 14. No, it's a 16. That all of this TTL logic pin 1 is down, so you want the notch on the socket to align. You've seen me do this before. A little bit of blue painter's tape. When you peel it off, it doesn't leave any glue residue behind. It's a little spendy. But you can reuse these 3 pieces. I'll reuse for probably all of the sockets I'm going to solder up. Now I can push the board down flush, solder the outside 2 corners of all of these. Hopefully this is in frame. For me personally, I like being able to push the board down tight against the work surface, which is why I work from lowest height to highest height. And we installed one over here. Painter's tape comes off. I look to see if they're all flush. Now I'm going to end up reheating the corners and just making sure they're really flush. Even though they looked flush. Again, not a critical step. But I'd rather do a good job than a bad. And we will step through these. Solder them up. Some people like to use an assembly jig to hold the board. I guess if I'd have grown up doing that, it might make more sense. If it works for you, of course, use whatever process works for you. Ouch, a little piece of wire on the bench just stabbed me in the arm. I've mentioned this before, but I'll mention it again. I am also reflowing the 2 pins I originally soldered. I already said these are double wipe sockets, so they're a little more reliable. If I was super concerned about long-term reliability, I'd be using machine pinned sockets. They're fairly spendy. I don't have a whole lot in my inventory, and I'm just not going to worry about it. I don't think in this case it's worth it. I think in the pictures I saw of the board Alberto built, he did use machine pin sockets. In kind of personal preference, avoid single wipe sockets. I actually got a great deal. They're an industrial sale on sockets and bought a ton of 14 and 16s, and after I got home and looked closer at them, they were single wipe, and I got them for like a penny a socket, but it was like, well, crud. And they went off to electronics recycler. I have no idea what they did with them. They probably just threw them in the trash, honestly. But not a whole lot of metal reclaim in a socket, or they may have resold them. I have no idea. But I was pretty disappointed to get home and discover the, $30 in sockets I had bought, because it was a huge quantity, were all single wipe. And we have 3 of the sockets in place. I will not bore you watching me solder the rest of these up, but I'll get them soldered up and we'll come back.